take a look at how to find a sum for an infinite geometric series. So here's my example. The series goes on forever and ever. So logically it seems like we shouldn't be able to get a sum. However, I'm going to look at this by modeling this example using a sheet of paper. So let's assume we have a sheet of paper. If I wanted to model or demonstrate half that sheet of paper, there would be a half. I could split that other section in half again, in which that piece would represent a fourth of the sheet of paper. I could continue doing this. At no point, as I keep breaking these things in half, at no point would I go beyond the boundary of this sheet of paper. That means the sum for this series is actually equal to the value of 1. Infinite series could converge or diverge. If something converges, it means that it comes together. If something diverges, it's getting wider or splitting apart. So if a series converges, you will be able to find a sum. Otherwise, you can't get an answer. If I take a look at my top example, it is geometric because my common ratio is 3. My numbers keep going up to infinity. There is no possible way for me to add all those numbers together. So in this top example, we would say that this one diverges. There is no sum. My next two examples, the one in the middle, my numbers are getting smaller and smaller and smaller. It is similar to the first example of the 1/2 plus 1/4 plus 1/8. I should be able to get an answer. My two bottom examples will converge. Something that we need to be aware of. I have the formula off to the side of how we find sum of geometric series. However, I can't substitute infinity in place of that, so I'm not going to be able to use this formula anymore for an infinite series. Now my top example diverges. I need you to focus on these ratios. That's what's the key in figuring out if it will have a sum or not. So if a series converges, something we need to look for, my common ratio. Now whether it's positive or negative, it doesn't matter, so I'm going to make that the absolute value of my ratio needs to be less than the number 1. Otherwise, if it's greater or even equal to 1, you won't be able to get a sum. It's going to diverge. So here's my new formula for finding that sum for an infinite series. Now keep in mind the one at the bottom would be for finite series. The one at the top is now for an infinite one. However, we need to make sure our criteria, our absolute value of that common ratio has to be less than 1. Otherwise, it won't have a sum. So we're going to revisit these examples. The top one doesn't have a sum. My middle one. Now if I'm using my new formula, and I'm just going to put that off to the side. My first term is the number 2. In my denominator, I would have 1 subtract 2/3. So that becomes 2 over 1/3. And when I divide with a fraction, that's the same thing as multiplying with its reciprocal. So I'm going to take it times 3 over 1, or just 3. That means the sum for that geometric series in the middle would be the value 6. In my third example, it is listed in sigma notation. You could list out some numbers if you choose to, and I'm just going to put a few in here. If I were finding my first 3 terms, this is what I would have. Now if I go back to that formula, my first term is the number 3. I would have 1 minus 1/4 of my denominator. And then I'm going to take my 3 times 4/3, because that's the reciprocal for 3/4. And I would get an answer of 4. So that means that that third infinite geometric series equals a value of 4.